Hello, my name is Jordan Horn, and I am here to discuss soap. Now, soap is something that almost all of us use every day, although few people understand how it actually works. There are a few basic principles of chemistry that will allow us to understand the function of soap. To begin, we start with the idea that likes dissolve likes. And in the realm of chemistry, this means that nonpolar dissolves nonpolar, and polar dissolves polar. Now, these may be some unfamiliar terms to many in the audience, so we will take a brief detour to discuss some basic chemical concepts. We will start with the periodic trend of electronegativity, seen in the photo here increasing as we move up and right on the periodic table. Electronegativity refers to how strong one atom pulls for electrons, and is determined by the number of protons in the nucleus and also the shielding caused by the core electrons. Now, this is beyond the scope of this lecture, so for now we will discuss the consequences of electronegativity rather than the causes. In chemistry, atoms form covalent bonds by sharing electrons between two nuclei. The more electronegative nucleus will have a stronger attraction on the shared electrons, and the electrons will spend more time closer to that atom. This creates a charge imbalance known as a dipole. A bond that has this dipole characteristic is known as a polar bond. Now, when two atoms with similar electronegativities are bonded together, they will not exhibit this behavior and will form what is known as a nonpolar bond. Polar bonds allow for the opportunity to create both polar and nonpolar molecules. This is determined by the structure of the molecule. If we look at H2O, we can see a dipole is formed by its bent shape as the oxygen pulls the shared electrons away from the two hydrogens, creating a charge distribution on one side. If we were to examine a nonpolar molecule such as methane, we see polar bonds between carbon and hydrogen, but they are arranged in such a way that the charge distribution cancels out. So now, let's apply our new knowledge of polarity to cleaning with soap. Dirt and oil are nonpolar molecules like methane, and therefore cannot be washed away by water. However, if we introduce a soap molecule, this becomes possible. All different kinds of soap share the same general structure, consisting of a long carbon chain forming the nonpolar tail with a polar top. Now, the nonpolar tail is able to bind to dirt and grease and other nonpolar molecules, while the polar top is able to be washed away or dissolved by water. Now, when many of these soap molecules surround a nonpolar molecule like dirt, it forms what we call a micelle. We can see here that what we have left of the micelle is a sphere consisting of all polar tops, which can be dissolved and washed away by water. This explains why you are unable to clean greasy dishes with water alone. When you use soap in the shower, it will often leave your skin feeling dry, and this is because the soap is allowing the oil in your skin to be washed away. We have now examined the chemical structure of soap and taken steps to understand how its structure determines its function. We have also discussed several crucial concepts of chemistry to aid in our understanding. Whether you're using soap to wash your hands, dishes, or clothes, the chemistry behind the cleaning is all the same.